Space, the final frontier. These are the voyages of the starship Enterprise. Its 5-year mission: to explore strange new worlds, to seek out new life and new civilizations, to boldly go where no man has gone before.
There is overwhelming evidence and scientific consensus that the Earth is not flat, but rather an oblate spheroid, meaning it is mostly spherical with a slight bulge at the equator. Here are some compelling reasons supported by scientific research. 1. Satellite imagery. High-resolution satellite images and photos taken from space clearly show the curvature of the Earth. Pictures from various space missions, such as those from NASA and other space agencies, consistently depict a spherical planet. 2. Horizon curvature. Observing the horizon from different altitudes, such as from a tall building or an airplane, reveals the curvature of the Earth. As you gain altitude, you can see the horizon dropping away, proving the Earth's spherical shape. 3. Gravity. Gravity acts as if Earth is a massive sphere, pulling everything toward its center. The distribution of mass in a spherical object creates a gravitational force that aligns with our observations and measurements. 4. Circumnavigation. Numerous circumnavigation voyages have been made around the Earth, consistently ending up where they began. This would not be possible if the Earth were flat. 5. Time zones. The existence of time zones is another indication of a spherical Earth. As different parts of the Earth rotate towards or away from the Sun, they experience different times of day. 6. Star positions. The positions of stars change as you move from one hemisphere to another. This phenomenon is consistent with a spherical Earth, but cannot be explained if the Earth were flat. Gravity's effect on mass distribution. The Earth's gravitational pull causes oceans to form a roughly spherical shape, creating the tides. This effect is not consistent with a flat Earth model. 8. Shadow during lunar eclipses. During a lunar eclipse, the Earth casts a curved shadow on the Moon. 9. Measurements from space missions. Various space missions and satellites, such as GPS satellites, would not function correctly if the Earth were flat. 10. Eratosthenes' experiment. Around 240 BCE, the Greek mathematician Eratosthenes measured the Earth's circumference using the differences in shadow angles between two cities, Alexandria and Siena. His calculations were remarkably accurate and only make sense on a spherical Earth. The flat Earth theory is a belief that the Earth is flat rather than spherical. According to this theory, the Earth is a flat, disc-shaped object, and its existence as a globe is considered a conspiracy or a misconception perpetrated by governments and scientific organizations. It's important to note that the idea of a flat Earth was widely believed in ancient civilizations before scientific evidence demonstrated otherwise. The understanding of a spherical Earth has been firmly established for centuries through various empirical evidence, including observations of the Earth's curvature from tall structures, circumnavigation of the globe, satellite imagery, and space exploration. The modern resurgence of the flat Earth theory can be attributed in part to the Internet and the ease of sharing information and ideas online. Despite overwhelming scientific evidence supporting a spherical Earth, there are still individuals who subscribe to this theory. Some proponents argue that there is a global conspiracy among scientists, governments, and space agencies to deceive the public about the Earth's true shape. It is essential to emphasize that the overwhelming consensus among the scientific community is that the Earth is an oblate spheroid, slightly flattened at the poles and bulging at the equator due to its rotation. The evidence for a spherical Earth is substantial and corroborated by multiple independent lines of inquiry and observation. In summary, the flat Earth theory is not supported by scientific evidence and is considered a fringe belief, largely rejected by the scientific community. The Spherical Earth Theory, also known as the Globe Earth Theory, is the scientific understanding that the Earth is approximately spherical in shape. This theory has been widely accepted for centuries and is supported by extensive scientific evidence and observations. Key evidence supporting the spherical Earth includes 1. Gravity. Gravity pulls all objects toward the center of mass, and a spherical shape is the most stable configuration for a massive object like the Earth. 2. Earth's shadow during lunar eclipses. During a lunar eclipse, when the Earth comes between the Sun and the Moon, the shadow cast on the Moon's surface is consistently round, showing the curvature of the Earth. 3. Horizon. Observers at different locations on the Earth's surface can see different stars and constellations near the horizon, which would not be possible if the Earth were flat. 4. Ships on the horizon. As a ship moves away from an observer on a coastline, it gradually disappears below the horizon due to the curvature of the Earth. 5. Airplane flights. Airplane routes and flight times are calculated based on the Earth's curvature, and long-haul flights take advantage of the Earth's spherical shape for efficiency. 6. Satellite imagery. Images captured from satellites show the Earth's spherical shape, and there are many live streams from space stations, further confirming the Earth's roundness. 7. Gravity's variation. The slight variations in gravity across the Earth's surface are consistent with the expected patterns on a spherical object. 8. Earth's shadow on the Moon. During a lunar eclipse, the shadow cast on the Moon's surface is always round, regardless of the observer's location on Earth. These are just some of the many lines of evidence that have led to the overwhelming scientific consensus that the Earth is spherical in shape. The concept of a spherical Earth is a fundamental aspect of modern geodesy, cartography, and global navigation, among many other fields. It is important to recognize that the spherical Earth theory is not a mere hypothesis, but a well-established scientific fact based on a multitude of empirical data and observations.